please, Pino Rosolini, Giuseppe Rosolini from University di Genova. We talk about the Comonad of identities.
Thank you, Beppe. Thank you very much. Thank you, everybody, because it's really an honor to be on stage at the ItaCa Fest Christmas edition. It's been a great time for me to attend virtually all your meetings. I always had lectures to give for my courses on Wednesdays afternoon, and in fact, I found it was almost more enjoyable to attend lectures recorded, because anytime I wanted to rewind and understand something I've missed, it was very useful. You've done a great job. Thank you very much. And well, I can't see how many people are still here. It's been a great meeting through the day. I had a title which I really thought would put a lot of people down, because after all, what can you do with the identity monad, or the identity comonad? After all, is the same trivial example. In fact, it's not the identity monad. I hope you can see my pointer on the screen. It's the comonad that speaks of what we mean by identities. I hope to explain this to you. Before I forget, I have to mention that this work would not have been done if I wouldn't have shared the collaboration of Jacopo Emenegger and Fabio Pasquali. Their ideas are everywhere in all the pages you see, if I'll be able to share some of the other pages. Let's see how it goes with the next one. Can you see it?
Yes, I can.
It's a new page, isn't it? Let me address, first of all, what I think I mean by categorical logic, or the way to look at logical properties using category theory. And my impression is that there are at least two ways, and one is that of understanding a category as a kind of universe where you can perform some part of mathematics, let's put it like this, and depending on the properties of the category, you get a different flavor of logic. And here I've listed as many names of categories as I could think, where it makes very good sense to speak of the internal logic of the category. And I've had dots here at the end, because I realized that I failed. The list is not complete. I should certainly explain that the main promoter for this point of view was Bill Lovier. I'm pretty sure you can't read the reference I have at the bottom. Now the pointer has disappeared. But that is one of the first papers where Bill explained his point of view, which has become a world point of view about how to deal with logic within category. In fact, in the paper on adjointness in foundations, he proposed an even more general approach to logic, and not just seeing logic in categories, but seeing logic and studying it within category theory, as I said. And the crucial structure that he pointed out was that of an indexed preorder, or if you like, even more generally, an index category. This has been named in various different, with various different names through the years. The first that probably Bill used, or at least on paper, was hyperdoctrine. That later became existential elementary doctrine. Then there were particular doctrines or hyperdoctrines, if you like, that were called triposes. Well, they are, after all, just index preorders. And in fact, as I mentioned, the straightforward generalization from preorders to categories yields the point of view on logic, which can be dated back to the French school of Grothendieck and the others, with fibrations and all the variations of fibrations that you can think of, starting with this modification for elementary, which is here. In particular, from this point of view, looking at logic in category theory allowed to look at logic in categories from the first point of view, where you essentially consider the index preorder of subobjects on a given category with enough structure. Let me put it like this. In the present talk, I would like to concentrate on just the elementary notion, both elementary doctrines and elementary fibrations. The point of view is what I would say goes to what is unfortunately called, but since it is in the literature, I do wish to mention it, the propositionist types paradigm. And I'd like to point out the categorical approach to this paradigm, or whatever it is. And it goes simply with the remark that the category, the preorder on two objects, the non-trivial preorder on two objects, fully includes into the category of sets with the reflection. The reflection I call it inhabitation because it sends a set to the amount by which it is inhabited. In other words, it sends the empty set to the initial object in 2 and any other set in the terminal object in 2, and there are no other objects in the category 2. This extends immediately by enrichment, as we've seen already today, to the category, to the connection between categories and preorders, where preorders are in a sense the vestiges of what remains of a category once you forget the names of all the arrows. And the adjunction that one gets between categories and preorders reflects, extends yet, if you want, to the connection between indexed categories and indexed preorders. And while I was preparing my slides and I was thinking about this, and I realized that I had to mention the proposition as types, I remembered this picture, and which definitely goes back again, at least for what I can tell, to Bill Lovier and to that paper of '69, which reports work that he had done in the 2 years before that, reminded me of what this picture always meant to my friend Aurelio Carboni. He left us some time ago, and it was a great loss, especially for Italian category theory, because after all, it connected me once I thought of him to what had happened 30 years ago. And since there are lots of Italian category theories connected now in this strange lecture room, I wanted to remind you all of what had happened in Como 30 years ago. I could not find a picture of Villa Olmo on the web that resembled what it was 30 years ago. I'm very far from Como at the moment, I can, well, probably I could drive there, but I could certainly not go into the middle of the lake to take a picture like this. Also because, as far as I could tell from the various pictures I found on the web now, Villa Olmo does not look like that anymore. And the category theory meeting that we had there was really something that established the Italian group in category theory in a way that I could not foresee before the conference took place. And just because we are in a virtual lecture room now, I want to give you an idea of what the lecture room there we had to use. And I can tell you that the chairs are not those of 30 years ago, but they are very similar to those. And as you can see, there are no blackboards. And I remember that the attendees did not complain, because after all, the surrounding was enough to satisfy their attending a category theory meeting. And because that lecture room reminded me that we would have been on a virtual lecture room now, and because of the amazing result that I think the ItaCa group has achieved, I now want to ask for something which may sound blasphemous, and just because of that, I'm sure Aurelio would have liked it. I'm going to ask, and nobody can stop me because I'm in charge since I'm the main speaker at the moment. I'm going to ask everyone to open their microphones and at my tree give a real round of applause to the organizer of the ItaCa Fest. Ready? 1, 2, 3. Very good. I can see that we are a very good group. Congratulations. Let's go back to proposition as types.
Thank you, Pino.
Thank you, Pino.
Well, you're welcome. I don't know who
This
spoke,
was
but
not
never mind.
organized.
Let's not do that because I'm going to lose my screen again. Don't worry. We'll speak later. I may stress this a little too much, but as many of you know, the nomenclature proposition as types paradigm goes under various different names. And it's really amazing that nobody that uses that nomenclature understands that Bill Lovier was the one who started it. Okay, maybe Curry had a first go at it, but the real way we can use mathematically what propositions share with types comes from the picture that you have on the screen now, at least for what I understand, and the way Bill explained in many papers. Okay, as I mentioned, the proposition as types paradigm, or whatever you wish to call it, gives rise to a reflection of for index pre-orders from index categories, which I'm going to assume is equivalent to the category of fibrations. And if you're not happy about this equivalent, we can discuss about it, but it will not enter in any point of the presentation. Here, I've depicted the information about the two categories of index pre-orders. So a contravariant functor from a base category B into the category of pre-orders. One cells are pairs of a functor F bar and the natural transformation F hat Mind you, the natural transformation Fn, I know it's not at all clear from the picture, goes from the functor P into the composite functor Q F bar op, and the two cells are given by a pair. Well, the second is a property, is not really a piece of information, of a natural transformation between the functors and an inequality between the component-wise between the natural transformations. It's a lot easier, definitely. It's a much nicer picture in line with what Fosco was mentioning in the last talk about how category theory helps in packing information, to look at the category of fibrations, where I'm not going to tell you at the moment what a fibration as a functor is, but where you can see immediately what I mean by the two category of fibrations and functors among them, which of course have to preserve the underlying structure. Okay, so this is a quick recap for the connection between these two categories. And now let me specify what I mean by identity. Of course, when I say identity, I think of the identity function, of the identity functor, of the identity arrow in a category, but this is not what I mean. What I really think as identity is what it means to determine a concept by means of other characterization, like say, what is a prime number? And a prime number is a number for which the set of divisors has cardinality exactly 2. So I understand, for instance, that 6 is not a prime number because I can count and multiply and divide. Similarly, when I look at figures in the plane, I understand that the first two are triangles and the third one is not. But the way I understand it is because I understand identity as a quality of things, where things can be numbers, can be figures, and again, equality need not be what usual philosopher means, that something is only equal to itself. Equality is an extremely useful concept in mathematics, which can be analyzed and must be analyzed, especially using category theory. And we've seen examples of this through the day today. I stop a second to point out this very interesting reference of a non-recent paper by Dana Scott on identity and existence, which revise ideas like this. And now let me get into the prime subject of what I want to tell you in the next 20 minutes. I shall address the problem of understanding equality from a categorical point of view using index preorders, using fibrations. And in order to do that, I have to introduce preorders with structure. And the first one is the notion of primary doctrine. And because among us, there are many Italians, please keep in mind that primary doctrine is just a pun for what is later the notion of elementary doctrine, and primary must come before elementary. It's not very funny, but that's the only reason I can justify the name primary. And the structure required is that the base category has finite products, real finite products, and the fibers have finite products, which, since they are preorders, are exactly finite means, and also that all reindexing of the functor preserve finite means. This notion can be found not exactly in this form, but almost in this form in the paper by Bill. It is analyzed in the book by Bart Jacobs on categorical logic and type theory. With the name of primary doctrine was introduced by Millie Maietti and myself in this paper in 2013. Given this structure, I rush to give you examples. There are many examples. The power set functor from set into preorders is primary. And in fact, the subobject functor is primary whenever you can write this index preorder down. So when C has pullbacks and finite products, in other words, that it has finite limits. Also, when you fix a class of monomorphism in a category which are closed under isor and pullbacks in C, where I mean you can pull back any arrow in M along any arrow in C, then you can get a primary doctrine. Other examples which are in line with the point of view that I sketched at the beginning of the reflection from categories to preorders, consider a category with weak pullbacks and consider the assignment of any object of the category A with its poset of variations. The name variations was introduced by Grandis in a paper to mean exactly any arrow in the comma category over little a considered up to connected arrow and not necessarily monic. Suppose the category has weak pullbacks and consider this, suppose this is a weak pullback, then you can extend the assignment I just given you on objects on all arrows to determine an index preorder, and that index preorder is primary exactly when the base category A in this case has finite products, strong finite products, because I've only assumed that it had weak pullbacks. And mind you, a strong terminal object is not enough. Another example, which is typical from logic, which again is taken from Bill's work, consider any formal theory in a very simple fragment of first order logic. After all, I just need myths, so consider only conjunctions. Construct a category of context, which is almost by definition with finite products, and consider the assignment of the Lindenbaum algebra of well-formed formulas with free variables among a fixed list of variables x1, xn, with the preorder given by the formal consequence, provable consequence in the theory T. Then that assignment is also a doctrine, and re-indexing is given by substitution. There is a very deep analysis of this in the book by Paul Taylor on practical foundations. Another example, consider just a mid semi-lattice and consider the index preorder given by the powers of H with the pointwise order, that by the simple definition of change of base given by precomposition gives rise to an index preorder. Mind you, I've marked the arrow F in red because it goes in the opposite order, in the opposite direction in set. That's again a primary doctrine. I need the notion of primary doctrine in order to introduce the notion of elementary doctrine. Again, a notion which is found in one of the papers by Bill on the subject. And it is a special primary doctrine with further structure. Left adjoints to certain re-indexing along what we call parametrized diagonals. They are diagonals with a parameter, as you can see, and all these re-indexing have to have left adjoints. These left adjoints must satisfy Frobenius reciprocity. Examples again, well, the power set index preorder is elementary, and for any class of monos which come from a stable factorization system in C, you have left adjoints not just for the parameterized diagonals, but for all arrows. So in particular, also that is elementary. And it is essential to understand what goes on in elementary doctrines, a characterization theorem, which you can read, or I can read for you very briefly, where the notion of being elementary, which requires a family of left adjoints, can be reduced to the existence of a special object in these appropriate fibers. With these special objects, mind you, a family of objects like this, have to satisfy these three conditions. And rather than trying to explain those conditions to you, I'd rather go through some of the examples of elementary doctrines which can be proved to be elementary exactly using this characterization. And the first one, which is the logical example, is now the index pre-order given by the Lindenbaum algebras on a theory in the conjunction equality fragment of first order logic, where the first condition A, once you pick delta for an object X, it's a context, X of type T, you pick delta to be exactly the formula in two variables, X equal X prime, then the condition A becomes, where I've been extremely careful in writing down the correct substitution of all the variables, becomes exactly the fact that you know very well that is called the reflexivity property for identities. And the second condition explains what equality of n-tuples is, and you know that two n-tuples are equal exactly when the components match. And finally, the third condition is what goes under the name of the substitutivity property of equality. So in other words, the three conditions A, B, C simply reflect from a categorical point of view, from an index point of view, the logical properties of the equality predicate. And that is actually the intuition. Again, in another example, which one proves as an elementary doctrine using the characterization, the subobject doctrine for a category C with finite limits, again, the choice of the deltas are exactly what you expect, the diagonal embedding of an object into its double product. And the first condition A is just recognizing that the diagram, the square you see on the slide is a pullback. And similarly, condition B is recognizing that this other diagram is a pullback, where, just to mention, consider that, for instance, this arrow in the bottom side is exactly this re-indexing of the delta. And the one on the vertical right-hand side is this re-indexing of the delta. You see that there is the same projection in the second and fourth component. Well, and finally, it's another computation of a pullback in a category of finite limits, the external square, that gives us the way to see how to map the first subobject into the other subobject, which is this one. So if your intuition that elementary doctrines means to encapsulate the idea of identity, then we agree. If I've not convinced you, I'm sorry, but this is as well as I can do with these instruments. With the same kind of arguments, you prove also that the other examples of doctrines give elementary doctrines in the particular cases when you have weak pullbacks and finite products, and emit semi-lattice with the least element. The least element is needed in order to define Kronecker delta to work for the choice of the deltas. Well, I have to introduce the two categories I mentioned at the beginning. They're quite obvious. The index preorders, the primary doctrines, where the zero cells are just those index preorders, which are primary doctrines. The one cells are not just all the one cells of index preorders, but just those that preserve the structure. And the components preserved in meets requires commuting diagrams like those you see in the slide. And the two cells, well, we take all two cells. The other category is the category of elementary doctrines, which are particular primary doctrines. Again, the one cells are not all the one cells of the primary doctrines, but have to preserve the further structure, the further properties. It's difficult to say because the properties are essentially unique in primary doctrines and in elementary doctrines, but they are structure, and they preserve it up to isomorphism. So all this fact that the structure is present up to isomorphism gives rise to connections between the two categories of primary doctrines and elementary doctrines. In particular, there is a reflecting two functor from primary doctrines to elementary doctrines. Well, I'm afraid I don't have time to go through the other picture, but I'll let you look at the references which I list here on the slide if you're interested. In particular, I want to notice that the construction of R is almost identical to that of the functor that I've marked here with subscript Q. And it was a remark of Fabio Pasquali that the construction here, subscript Q, the functor subscript Q, actually, although applied on elementary doctrines, could very well be applied also to a primary doctrine, and to produce a co-free construction of elementary doctrines from primary doctrines. The fact is that co-free construction is much more than that. In the diagram you see, well, these two adjunctions give rise to a two-monad on PD, and that two-comonad determines a category of pseudo-T coalgebras, while the standard comparison functor between elementary doctrines and these pseudo coalgebras is actually a two equivalence. In other words, elementary doctrines are coalgebraics over primary doctrines. And I'm not going to present the proof of this. I'm just going to sketch very briefly the construction of the underlying functor for the two comonad, and I'm afraid I'm going to let you guess what are the other components of the structure. But the construction is something which occurs much too often in many cases in the categorical approach to logic. So suppose we are given a primary doctrine pre, I need to define the primary doctrine TP, where the base category is given as follows. It consists of a pair of an object of the base B and of an object in the same fiber as the fiber where we had to pick the deltas for the for the structure of an elementary doctrine. And very briefly, this object has to perform as if it was an identity, as if it was a delta. And the request one has to make are the following three. If you have looked at the previous condition here, you realize we write again what, from the logical point of view, I call the reflexivity property. And with the same kind of squinted eye, you can look at the fourth condition as a request for symmetry, and the final condition as a request for transitivity. In other words, rho, you should think of rho as a binary relation in the logic P of the category B, whatever that means, as an equivalence relation. The arrows in the category we have to define are homomorphisms of equivalence relations, if I can put it briefly. They are arrows on the base objects in C, which preserve the relation rho, which preserve the object rho. The pre-order, the indexing pre-order is given by descent data. This is the condition of substitutivity requested with respect to rho rather than with respect to delta. One proves that the indexing P gives rise to an indexing, to a correct indexing on this new piece of data, and that defines the underlying functor for the comonad. And I'm sorry, I've given you enough references, and I'm certainly available together with my co-authors to give you more details if you're interested. So we have seen elementary doctrines are coalgebras, and now I'm sorry, I'm going to switch from the pre-order case to the categorical case, to the Enriched case, because in the same way, we can prove that elementary fibrations are pseudo-2 coalgebras, where we've changed the two category of primary doctrines into the two category of primary fibrations, whatever they are, and similarly for elementary doctrines to elementary fibrations. It's not surprising. This is how it always looks in category theory if you use category theory right. I know this doesn't sound very modest, but it's a praise for category theory rather than for what we have done. The details are much worse. I have 5 minutes. Do I have 5 minutes?
Yes, please.
In 5 minutes, I'm going to try and convince you that we have a proof also for this. In fact, I'll have to go through quickly what it means to renounce faithfulness, going from a primary fibration to a fibration with finite products. That is the appropriate, possibly appropriate version of the proposition as types paradigm declined as category theory. And so the request is that the base category be has finite products, and every fiber has finite products. This is equivalent, as Bart Jacobs proved in the book, to have the two categories with finite products and requesting the fibration functor preserves them. Similarly, elementary fibrations have to be restated, but the condition doesn't change much. Once we get adapted to the language of fibrations, the parameterized diagonals remain what they are, because after all they are in the base, and the left adjoints along reindexing have to satisfy Frobenius reciprocity and Beck-Chevalley condition. Again, oh yes, before I move on, I have to remind myself and all of you about the notation you may see in diagrams in the total category of the fibration. If I have a Cartesian map over a map in the base category, I will use this round point in order to remind me that it is Cartesian. And again, there is a characterization for elementary fibrations, which is very similar to the characterization theorem for elementary doctrines. In order to explain the characterization, I have to explain to you what it means for a fibration to have, strict productive transporters, and to make sure that every arrow in this fancy family Xi is locally epic. Well, no, I'm sorry, I will not manage. Just very quickly, strictly productive transporters remind you of the three conditions we had in the characterization of elementary doctrines. Local epicity has to do with the new enrichment. Rather than being on 2, we are now enriching over set and uniqueness count. And local epicity is essentially the uniqueness condition that one would require in order to make sure, for instance, that the epsilon arrow up there is a co-Cartesian lifting for the arrow below. Not just the existence, but the uniqueness condition. When we have the two equalities, especially the one below, then we already have that the two arrows are the same. In other words, any map factoring 2 epsilon factors uniquely once it does so in the base category. With that condition, I'm going to skip this example. We have the final result, and that I've mentioned. The proof, again, I'm not going to mention it, but I'm going to give you the construction of the functor. It consists this time of, again, the glorified version of the pre-order situation, which one says, well, it looks like a groupoid, and amazingly, luckily, it is exactly a groupoid in the total category, but it's a groupoid which is strongly anchored to the base. In particular, the object of the groupoid must be the trivial object in the fiber where that object is, and the groupoid structure must live above the trivial total groupoid on the base object B. And with this, I think I've told you all I wanted, and I'm available for any question. Thank you very much.
Thank you, Pino, for your talk. Are there any questions or comments?
Yeah,
please.
It's Walter Toven here. Pino, thank you for your wonderful talk that couldn't be compromised by technology. I'm very grateful that you alluded to Bill and to that great meeting in 1990 at the Villa Olmo. I have very vivid memory of this wonderful meeting organized by Aurelio and Bob Walters. It was one of the, not just for Italian category theory important meeting, but really truly internationally. It was a world meeting. It was a wonderful meeting. Maybe one slight correction. I don't think it was the beginning of Italian category theory, even though it was a great boost for it, but it was sort of a culminating point of a very successful decade during the 70s that started with Bill O'Veer's Perugia lectures and at other places in Italy, and that helped nurturing quite a successful big crew of Italian category theorists that included Marco, Renato Betti, you of course, but you were younger. But then there were other young people like Cristina Pedicchio and so on, who all benefited from this great development in the 1970s in Italy. I'm, of course, also very, very happy that you alluded and started off with Bill O'Veer's take on the comprehension scheme. It's sort of funny because just last night I posted a paper that I've written with a postdoc of mine, Leila Yegane, on where we prove the comprehensive factorization in an arbitrary T category in the sense of Buroni. And it's sort of a funny coincidence. One of the people that had an early sort of or different categorification of this comprehension scheme of builds was John Gray. There is an interesting article, early article of his in the lecture notes 1990, where he alludes to Bill's lectures of the time and takes that into a slightly different direction that we then pursued to establish this street voters type of comprehensive factorization in a different context. Well, it's just a long remark, but I truly enjoyed your lecture. Thank you, Pino.
Thank you very much, Walter. If I may follow on what you said, first of all, since you're here, I go back to the only slide I had to skip, and I had to skip it, let's face it, I had to skip it because I want to make myself a clown when we thanked all the organizers of the ItaCa meeting. But an extremely interesting example, I skipped the example of elementary fibrations. A very interesting example of elementary fibrations comes using algebraic weak factorization systems, which, correct me if I'm wrong, you and Marco called natural weak factorization systems in your original paper. That is an extremely interesting structure, and the fact that without it, a category with a factorization system, with a weak factorization system, does not produce an elementary fibration. Not, at least we've not been able to do it. Is pointing in a direction which is very, very interesting about coherence problems and how one has to tackle them in the enriched case. And let me you mentioned Bob Walters. You are absolutely correct. I was very quick when I said that it was the beginning, but of category theory in Italy. I was wrong. I see it now with the eyes of the old mathematician. As you said, I was young then, and you were young too then. But I see so many young people here, and what I was thinking is that all of them missed a fantastic place like Como was in that year. And again, I didn't mention the organizers of that conference. The CT90 was hosted in Como with the support of Aurelio, Maria Cristina Pedicchio, and myself. Bob Walters at the time was not resident in Italy yet, and in fact he contributed very much to the second edition of an Italian International Category Theory Conference in 2000, which was again a huge conference. And thank you again.
Okay, good.
Thank you, Pino. Thank you very much for your very kind words also about this ItaCa we are keeping. And in fact, you are right. We couldn't, most of us, I mean the young people, the younger than me, of course, couldn't be at Common 90 because we were children or even not born yet, not born. But that's why we are trying to do something now for the future, because we want to live new lives in category theory in Italy, and this is the bright future we are facing, hopefully.
Absolutely. As I say, with all my experience of category theory meetings around the world and in Italy in particular, what you're doing now is a huge success. I hope I can be at the meeting you've organized. Please send a reminder. It's sometime mid-January. I intend to be there, and I hope to convince whoever has to be convinced to continue doing this, because it's extremely useful.
So in fact, in January, we will have this meeting, which will be sort of organizing. And I mean, we have to make the point of what we have done and make another point of what we are going to do. So this is the reason why we are organizing this new meeting in January. And so we will advertise it with all the means. So you will have all the detailed information in due time. Okay, so I think that we can, if there are no other questions, because you can still have some minutes because you started later. So
I have one question. Maybe I can ask it later if you want to close.
well, since the meeting was scheduled until 4 o'clock, I think that it's fair that we can close officially the meeting. And so say thank again, everybody. I'd like to thank also the Fosco and Daniele, because they organized the website, and so they make this really nice job and very useful. And without the site, I think we couldn't have organized all this. So it's very important to acknowledge this, and say again thank you to everybody, and that's it. So bye bye. Whoever wants can remain. I stopped the recording. So